Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Swirling Swiss on Rye by Not Very Neat. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have arrows, where digits along an arrow sum to the number in the attached circle. So, for example, if this were, say, 2 and 5, this would have to be a 7, because the digits along the arrow must sum to the digit in the attached circle. And 2 and 5 equals 7. And that's an example of how arrows work. And we have sandwich sums, where clues outside the grid indicates the sum of the digits between the 1 and the 9 in that row slash column. So in this column here, the digits between 1 and 9 must add up to 9. So you could have something like 9 being here, 1 being here, and the digits in between are 2, 3, and 4. And that would be valid because the digits between 1 and 9 in this column are add up to 9, I should say. And that's an example of how sandwich sums work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. All of these digits in the central box are the sum of 3 unique digits, right? So, because of that, we know these have to be the digits 6 through 9. Should we? I don't even know. Let's just make it 6 through 9. Because the minimum of 3 unique digits added up together is 1 plus 2 plus 3, which adds up to 6. These must all be unique digits because they're in the same box. So these digits on the arrows must be 1 through 6. Now, what else do we know? To add up to 32 in between a 1 and a 9 in a row, that means you can only have one digit outside. The remaining digits between 1 and 9 add up to 35. And you can't remove 2 digits because you don't have a 1 available. You have 2 through 8 that you can remove. So to get from 35 to 32, you have to remove 3 total. And the only way you can remove 3 from 2 through 8 is removing a 3. Well, where is 9 in row 3 then? It has to be either at the end or in one of the cells that are next to the end, right? Because we're missing only one digit, that is the 3. So 3 cannot be anywhere inside. It has to be outside the sandwich. And the crust has to be 1 and 9. Well, 9 cannot be either of these digits here. So that means we have to have 9 has to be on the outside cell, and then 3 has to be the other digit. So this must be 3 and 9 and 3 and 9, because we're missing the 3 between the sandwich, and the 9 has to be the other one, because 9 can't be one of these 2 digits. And if we have 9 anywhere else, the problem is those digits will not add up to 32, because we have too few in between the 9 and the 1. 1 cannot be, then 1 has to be one of these 2 digits here. So that eliminates 1 from the rest of the row. So this is definitely a crust. Well, okay, one of these two is a crust. And one of these two is a crust, so the rest cannot be crust. That means we are guaranteed a 1 here or a 1 here. If this is not 1, this has to be 2, 4, and 5 at minimum, which adds up to 11, which is not a single digit. So 1 has to be here, which means to be between 1 and 9, the 9 has to be here, and this is 3. So this is 1, and it's either 2 and 4, 2 and 5, or 2 and 6. So we're guaranteed a 2 here. This cannot be 2 here then. This is 4, 5, and 6. Which means this is not 6 adding up. 1, 2, 3. So this is a crust, and this is a crust, which means these are not crust here. This can't be 1, 2, or 3. It's at minimum 4. So we have 4, and this adds up to at most 8. Because it cannot be 9, because of 9 in the row. So this is 4 and 1 at minimum. So that would add up to 5. So this has to be 5, 6, 7, 8. And this could be 4 through 7 here. So this could be 1 through 3. It cannot be 4, 5. If this is 4, this has to be 5 at minimum, which adds up to 9, which we can't have because of a 9 in the box. If this is 5, this is 4 at minimum, and again, that adds up to 9, and that's not possible. So this has to be 1, 2, or 3. This is guaranteed to have 4, 5, or 6, so this cannot have 1, 2, 3 here, so this cannot be a 6. So we know one of these is guaranteed to have a 6. Well, where can 1 be? 1 cannot be either of these, because this column here has to have, right, it has to have the 1 and the 9 be next to each other, because between them has to be no digits, right, because they add up to 0. So 1 cannot be here. Well, what is the minimum now here? It's 2, 3, and 4, which adds up to exactly 9, which is the maximum for this circle. So then this can't be 4. This is then 2 and 3, and this is 4, which add up to 9 here. So these are not crust. 4 eliminates 4 from being here, so this is 5, 6, 7 at minimum. So this cannot be 5 here. This is 2, 3, and 4, which eliminates 2, 3, and 4 in the rest of the column. 9 eliminates 9 in the rest of the central box. So 6 is guaranteed to be here. That means we have to have a 1 guaranteed here, because to add up to 6, 7, or 8, you're guaranteed with 3 unique digits to have a 1, right? 6 is 1, 2, 3 added up. 7 is 1, 2, 4 added up. 8 can be 1, 2, 5 or 1, 3, 4 added up. So none of these can be 6 anymore, so this can't be 6. And this can't be 6. But we're guaranteed one of these is a 1. So this cannot be 1 here. We're guaranteed one of these is a 1. And to add up to 31 between the 1 and the 9, we can only be missing 4 total. Well, 2 and 3 at minimum only adds up to 5, which is too much. So therefore we have to be missing a 4. And the 1 and the 9 have to be surrounding everything except for the 4. So 9 can be one of these two, and 1 has to be one of these two. So everything in between cannot be crust. So we have 1 here, and then 9 be one of those two. The 4 has to be, this 4 eliminates 4 in the rest of the row. So this is 1, 2, 5 as a triplet, adding up to 8. So this is 8 here, which means this can't be 8 here. That means this is 6 or 7, so this cannot be 5 here. This is 1. 1 eliminates 1 as a possibility here, and it cannot be 5 with it. It's guaranteed to have a 2 here. These can't be 5 either because they add up to 7 at most. So we're guaranteed a 2 here, which means this cannot be 2. So this is 1, 2, 3, 4. This can't be 5 because of the 2, 5 pair in the row. So 6, 7. Where is the 8 in this row? It cannot be here because of 8 in the column. So this is 8, which forces this to be 6 and 7. This is 1 and 6 at minimum. So this has to be 7 or 8. And this can't be 3 because of the 3. 3 and 6 would add up to 9 at minimum. This is 1. So that means the crust for the sandwich must be one of these two. And this cannot be a 9 because 9 plus another digit is going to add up to 10 and more, which is not a digit. So this cannot be 9, which means this has to be a 9 here. So these are not crust then, between 1 and 9. This has to be 9. Remaining digits. If column 3, we have, this is 5 through 8. And no 8 here because of 8 in the row. This is guaranteed to be a 1-2 pair. So we cannot have 1 there because that would force 2 to be there. And we'd be missing 2 and no other digit, which would not add up to 31. So this must be 1 and is crust, which makes this 2 here. This cannot have a 4, so this is 3, which makes this 6, and that's 7. So then this is a 2-4 pair here. So this is not crust. We need crust to be here, and then this is not crust. So we have all the crust in, both of the crusts in this upper right-hand box. This is 4. 2 eliminates 2 here, so it's 5 and 2. This is 9. This must add up to 21 for these. So it must be at least 3 digits, which means 9 has to be one of these 3. Well, if 9 were here, the problem is these would add up to greater than 7. So 9 cannot be here. Can we be missing... Yes, we could be missing 2 digits only, which add up to 14, which 35 minus 21 is 14. But remaining digits in this upper right-hand box are 2, 6, 7, 8. So this cannot be 9 here because well, we can't have 9. So all of these cells see both 1 and 9. So this cannot be 1 or 9 here. So none of those are crust. So this has to go this way for the crust. And it cannot be here because that's not going to add up to 7. So it has to be here. So this is crust and 9. We can eliminate the rest of the row for being crust. And if this were 4, it would have to be 3 here to add up to 7, but this we already have a 3 in the row. So this is 2 and 5, which makes that 4 to add up to 7. That means the remaining digits in row 7 are 6, 7, 8. We know 9 has to be one of these two. So that means these cannot be crust here in this right central box. This can't be 1 or 9, so that can't be crust. This is crust here. None of these are crust. This can't be crust because it's not 1 or 9. That means 9 cannot be here. In row 5, it can't be here because of 9's in the boxes, so 9 has to be here. Okay, this can't be 9 or 1, so no crust there. And the reason why is because 9 can't be any of these, because it has to have 3 digits at least to add up to 21 in between the 1 and the 9. One of these is a 9. We don't know which. This, though, has to be at least 6 through 9 here to add up to 5 at minimum. 1, 3, and 4 is possible. Remaining digits, where's 2 in the central box? Can't be here, can't be here, so it must be here. Remaining digits in the central box are 1, 3, 4, and 5. Okay. Can this ever be 1? I think the answer to that is, well, maybe. You could have 2, 3, and 4 here, or 2, 3, and 4 there. And then that would be... One of these is definitely 9. So 1 cannot be any of these digits here. Because if 1 were here, that's not... The digits in between here already add up to 10. So these cannot be 1 here, which means where's 1 in the box, it must be there. So that's a crust, which eliminates crust from the rest of the box and column. We have to have a 9 with the digits adding up in between, adding up to 11. It could be 2 digits or 3 digits, but it can't be here because of 9 in the column. So it must be 3 digits because it can't be 4 digits because the minimum of 4 digits is 2, 3, 4, 5, which adds up to 14, which is too big. So therefore, this is the crust here, and this is 9. That eliminates crust from the rest of the row. 1 is guaranteed to be one of those digits here. These add up to 11 without a 4. The only 3 digits then that add up to 11 without a 4 are 2, 3, and 6. And this can't be 2 or 3 because of the 2, 3 pair in the box. So this is 6, and this is 2 and 3, which eliminates 2, 3, and 6 in the rest of the row. No 2 or 6 here. 2 eliminates 2 here. So that's 3 and 2, which makes that 3. That leaves this digit. These are 7, 8 as a pair, which eliminates 7, 8 in the rest of the box and row. So this can't be 7 or 8. It's 5, which eliminates 5 in the rest of the column. 6 eliminates 6 here, so that's 7, which makes that 6. 7 plus 1 only adds up to a valid number. So this is 7, 1, that's 8. This is crust. That means these must be in between because 9 cannot be any of these digits. So this must be crust, and this must be 2 and 3. So we have 3 here and 2 here because this can't be 2 because of 2 in the row. That leaves this as a 9, and this can't be 6, 7, or 9 now. So this is 8, which eliminates 8 in the rest of the box. That leaves this digit as a 5. Where is 8 in column 3? Can't be here anymore because of 8 in the box. Can't be here because of 8 in the row. So this must be 8 there. Okay, remaining digits of this lower left-hand box are 2 and 3. And 2 can't be here because of 2 in the row. So that's 3, which makes that 2. This can't be 3 anymore. It cannot be 4. Because 4 plus 5 adds up to a minimum of 9. And this can't be 1 or 9 here. Where is 1? This can't be 4 again, so this must be 1, which 1 and 7 add up to 8. So this is crust here, which means this can't be 1 here. That means this can't be 1 here, so that must make this 1. And these are not crust. These can't be crust. This 9 eliminates 9 from being here, so that can't be crust. This is crust here. So, and these can't be crust because they have the 1, 9 in the column, so this must be crust here. So this is 1, this is 9. The digits outside of the sandwich must add up to 35 minus 21, which is 14. So this is 6 and 8. 6 and 8 here, which makes that 7 and 2. This has to be crust because 1 can't be here, 1 can't be here, 1 has to be here. No 8 here. We have a 6, 7 pair. 7 eliminates 7 here, so that's 6, which makes this 5. This can't be 5 or 7, it's 6. 6 eliminates 6 here, so it's 7, which makes this 8 here. And the rest we can do from normal Sudoku. 3 eliminates 3 here. Yeah, because we already have 4 outside here, so that's fine. We have 14 outside here, so this is fine. And then we have 3 outside here, that's fine. This adds up to 9, this adds up to 11, and this adds up to 0. So then everything else is just normal Sudoku. We should have all the, we do have all the 1s and 9s. 2s, we have 8 2s. We know where the last 2 has to be. It has to be here. 3s, this can't be 3 anymore, so 3 in the central box must be there. 3 in column 5 cannot be here because of 3 in the row, so 3 has to be there. We have 8 threes. We know where the last 3 has to be. It has to be there. 4. Where is 4 in row 2? It cannot be here because of the 4-5 pair in the column. So this cannot be 4, which makes that a 4. 4 in column 5 can only be there. 4 in row 9 cannot be here because of 4 is in the boxes. These are filled out, so 4 has to be here. Where is 4 in column 8? Can't be here because of 4 in the box. The rest are filled out, so 4 has to be here, which makes this 5 and 4. And we have 8 fours, so we know where the last 4 has to be. It has to be there. 5. 5 in row... Well, in column 1 cannot be here because of 5 in the row here. So this is 5. 5 in row 4 cannot be any... These are filled out. Cannot be here because of 5 in the column. So 5 has to be there. That gives us 8 5s. We know where the last 5 has to be. It has to be there. 6s. 6 in column 4 cannot be here because of 6 in the box. The rest is filled out, so 6 has to be there. In row 5, can't be here because of 6 in the box, so it must be there. And we have 8 6s. We know where the last 6 has to be. It has to be there. 7 in row 2 has to be there. In row 4 has to be there. In row 5 has to be there. That leaves us the 7 in row 9 having to be there, and then the rest has to be 8. So 8 and 8. And that's how you solve it. Pretty cool, actually. I liked how the arrows and the sandwich clues interacted. And it was a nice little interesting foray there. Yeah, I'm not sure I'm not sure if there were other ways to approach this. It felt like this was sort of the path that we had to take, right, to be able to solve this. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.